morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Subinda with another video. So now we are continuing from where we left on. This is the last practice question under the second differential coefficient, which is the 2y, the x2. Alright, so we have this particular interesting practice question. At first glance, when you read through the question, it might look difficult. But when you start answering, start breaking it down into smaller components, you'll find that the question is quite easy. Okay, so let's get on with the answering of the question. The velocity v of a moving body whose position vector r is given by r is equal to xi plus yj, where x and y are functions of t. So this x and this y, these letters right there, are functions of t. Is the vector, okay, is the vector v is equal to dx dt I plus dy dt j. So it's given by a vector which is dx dt I plus dy dt j. Remember, they are saying x and y are functions of t. So when you differentiate x with respect to t, you're going to have your dx dt, and then you differentiate y with respect to t, you're going to have your dy dt. Okay. Then they're saying you look at figure 9.10. So this is figure 9.10 right here, where we have this curve. I don't know if you can see it. Let me just try to maybe thicken it. Okay? Okay, so here there is a curve. It's going like that. That's the curve. And then there is a direction of velocity. So this v is equal to that. It is the velocity of a moving body given by that particular vector. And then they are saying that the vector r is a position vector. Means it starts from the origin. Okay? It's a position vector like that. That is vector r. Then vector v, you can see that v is like that because we have the vector v there. So v is this one going upwards. Let me try to highlight it so that you can also see the vector v. Alright. I hope you have understood that particular diagram. Before I even go to the questions, you need to understand what is happening. That r is a position vector. Position v simply means I'm saying position vector. I didn't just have enough space to write the word vector. Then here, the vector v, it was said in the question that v is a vector. Then this is the path of the body, this curve. Okay, that's the path of the body. Okay, then question A reads, if r is equal to 2ti plus 5 minus tj, use the above to find the vector v. So this is vector v here, and then they want you to use all the information you have been given to find what vector v is. And then b says find the value of t for which v is perpendicular to r. So even before we go further, we can see that they're saying v is perpendicular to r. And what do we know about perpendicular vectors? Their dot product is 0. Why? Because vectors, okay, they use the cosine. They use cosine angle, the acute angle, or the angle that is the trig ratio rather, that is used is cosine. Okay? And cos 90, representing vectors being perpendicular. Okay? Like for example, this is the vector going up. It's starting from here going up. This is another vector. These are perpendicular. So the angle between them, alright, if you say cos 90 in your calculator, you type it, alright, it's going to give you 0. So let's answer this let's answer this question and let's see how we'll break it down. So we have the vector r is equal to xi plus yj. And then the question we have vector r being equal to 2ti plus 5 minus tj. They are saying this is vector r, then this is vector r. So these are two forms of writing vector r, which means that these vectors here, they are scalar multiples of each other. So what we're going to say, we're going to write equate vectors. So when we equate the vectors, it will be xi is equal to 2ti. So everything having I is going to be, so this is going to be equal to that. Then yj, alright, yj is equal to 5 minus tj, like that. We have equated the vectors. Then what we do is we drop vectors. So we are going to write drop vectors. Okay, this is going to become x is equal to 2t, y is equal to 5 minus t. As you can see now, we have two functions, alright? A function that is of x, a function of y, two functions. So where x and y are functions of t, and these functions have the variable t. You have seen that, that's what I was meaning. Okay, so we differentiate this function. We are going to say dx dt is going to be equal to 2, then here dy dt is going to be equal to negative 1. Dx dt is a 2, dy dt negative 1. Simple as that. So, remember, the question was saying that we need to use the above to find the vector v. Vector v is equal to dx dt I. So dx dt is 2. dy dt is negative 1, dy dt j. So what do? We just substitute. We clean up. As you can see, we will just say therefore, alright, v is equal to, that is 2i minus j. Simple as that. That is your vector v. And then we go to b. For our b, they are saying that we need to find the value of t for which vector v is perpendicular to vector r. Okay? So, to find the value of t, we are going to say vector v, the one that we have found is 2i minus j. Then vector r, okay, is this one. We're not going to use this one here where there was x and y. We're going to use this one having t because they want us to find the value of t. So r is equal to 2ti, okay, plus 5 minus t j. If they're perpendicular, it means that the multiplication of the x components and the y components, when you add them together, whatever you should get, whatever you have should give you 0. Okay. So the x component represents the I, then the y component represents the j. So the x component, which is 2i multiplied by 2ti, then here we're going to have ij multiplied by 5 minus tj. When I say it like that, someone might be confused. Well, what's really happening here? You need to know something, okay? You need to know I squared, you need to know j squared, and this is that I squared was going to give you a 1, j squared is going to give you a 1. What do I mean? I times I should give you 1. Now, another thing to note is that I times, you see this is, oh sorry, this is j, I, you can see that times j, this is actually going to give you 0. Take note. Why? Because I represents movement in that direction. This is j. J represents movement in that direction. Then I represents movement in that direction. Why am I saying this? I means movement in the x-axis, j movement in the y-axis, and the angle between them is 90 degrees, and because the angle between them is 90 degrees, therefore when you multiply them, the result you should get is 0, because the dot product of two vectors that are perpendicular is 0. Okay, so let us continue. Simple question, let's not make the video long. We are going to say, so since we know I times I is going to give you 1, we just get the numbers, the coefficients. Okay? So we have 2 multiplied by 2t, okay, plus a 1. Just put the square brackets because of where I'm going to write it. Plus a negative 1 there, the one in front of j is a negative 1 multiplied by 5 minus t should give you a 0. And then here I'm going to have 4t. You distribute the negative 1 in that bracket, minus 5 plus t is going to give you 0. 4t plus t, okay, 4t plus t minus 5 should give you 0. 4t plus t is 5t. Is going to be equal to positive 5. Divide both sides by a 5. 5 can go into itself 1, 5 can go into itself 1, into itself 1. T is equal to a 1. So this is the value of t, and that's the value of the vector v. If you stayed until the end of this video, I really appreciate, and I hope you have benefited something. Thank you so much for watching this video. This has been Cornelius Rubinda with another video, and bye bye.